Hi, guys. We are going to be reviewing everything, hopefully, you need to know about graphing and writing linear equations. We've worked a lot with this, and so just review our key ideas, and then I'm going to walk through some examples with you. So sometimes you may have a table of values where it tells you what the x value is and the corresponding y value. We write that as an ordered pair where the first number is your x value and the second number is your y value. And so what that means, if we were to plot that point, x is -1, so we're going to go over this direction, the negative direction, and y is 0, so it's going to be right there at that point. If we were to plot the next one, 0, 1, that means our x value is 0, our y value is 1, so it would be right there. Okay, do remember, just like in the alphabet, x comes first and then y. And you're always going to remember x is this horizontal axis and y is the vertical axis. Now, you may be asking, where did we get these values that are in this table? We have this equation y equals x plus 1. So if we pick any value for x, let's say x is 0, then we can substitute that in and solve for what y would be equal to. So we would know y would be equal to 1. So if x is 0, y is 1. Okay? Now, if we were to look at this part down below, we're talking about slope. The slope is the ratio of what we call rise over run, or the change in y over the change in x. So I want you to remember that when you're calculating slope, it's this up or down value that goes on top, and on the bottom is your left to right value, okay? Or this is your change in y over change in x. You have to remember that. Rise over run, okay? So just like on the example right below, right down there, you're noticing that we look at the change in y. So to go from this point to this point, how far down do we have to go? So you can draw little lines across there on the grid lines and say, well, we have to go in the positive direction, 3. And down here, we're actually going down. And you'll notice this line does have a negative slope. So remember, it's rise, the up and down part, over run. So we're going down 2, so we're going to put -2 over 3. Okay, so remember, this is our rise, but we're actually falling, so it's going to be a negative, and then we're moving to the positive direction, 3. So our slope would be -2/3. Now, if we're really just looking at points, we could look at this point on the graph that they have there. So if you look at the 2 points that they have on the graph, they have 0.18 and 0.46. So if we were to look at our y values, remember that's the second part of your ordered pair, we could say 6 minus 8. We're starting pulling the value from our second pair there, 6 minus 8, over 4 minus 1. Now remember, we pulled from that for our first number here. We pulled from that for our first number here. Okay, you can't mix up the order. So 6 minus 8 is -2, 4 minus 1 is 3. So even without graphing, you can take the two ordered pairs and calculate slope. Do take a quick look here and review that positive slope looks like that, negative slope looks like that. You should have that quick check in your brain all the time. Now, when you're graphing proportional relationships, you are going to remember it's always going to go through point 0, 0. Okay? And your basic equation would be y equals mx. We don't have the plus b at the end like we would have in slope intercept because we know the y-intercept is going to be at 0. So technically you could have y equals mx plus 0, but you don't need to add 0 technically. So your equation is just y equals mx. So just like we did in the ugly sweaters challenge, you might find y equals 3x or y equals 2x. And those would all show direct variation and pass through the point 0, 0, which we know as the origin. So here we are at slope-intercept form. This is probably going to be something you're really familiar with. You've heard it a lot. Y equals mx plus b. where the M represents slope and the B represents the y-intercept, okay, where it crosses this y-axis, okay? So step one, determine the slope. You can either do it from the graph, okay, like we just did in the first problem. So you're gonna figure out how far down you go for how far over you go. Remember, and it's the change in y over the change in x. Or you may do it from the ordered pairs, just like we did in the last example. Then you're gonna find the y-intercept, which is from your graph where it crosses that. Now, there are times that you are going to be given a slope and a point, and I want to show you how to solve that. So, if you are given a slope, you would rewrite your equation like this: y equals 2x plus b. Now, when we're given a point, we know our x value and we know our y value for some point that is on this line, right? Represented by this equation. So if we put our x value in here for x, we're going to say times 1, and our y value in here for y, then we can solve for what b is. Okay, in this case, 2 equals 2 plus b. We know b is going to be equal to 0. All right, so the equation for our line would be y equals 2x plus 0. But when we have the plus 0 there on the end, we don't necessarily have to add it. It would just go like that. It would vanish. Um, and this would be a line that shows direct variation because we don't have a different y-intercept. Or we know our y-intercept is at the origin at point 0, 0. So now let's try this with another point. Now we're going to do 0.32 because I want you guys to get used to this. It's really not super duper tricky. Once you just are able to identify, hey, I know this part. I know this part. That's my x value, and I know this part. And it's kind of like a game of Clue. If you have everything known except for one part, which here is our y-intercept, you can plug in all the known values and solve for the one unknown. So we have y equals, our slope is 2x plus b. But we know our x value is 3, so we're going to put that right there. And our y value is 2, okay? So we would say 2 equals 2 times 3 is 6 plus b. Well, we want to get b all by itself, so we're going to subtract 6 from both sides, and we end up with negative 4 equals b. And once we figure that out, then we have to put it back up in our equation, right? So we had our y equals mx plus b. We know our slope is 2, and we know our b value, or our y-intercept, is here at negative 4. So here is the equation for our line that would allow us to find any point on that line. So, fun way to use what you know in a game of Clue to figure out your unknown and then rewrite your equation so that you could find any other point on that line. Okay, standard form is a really great form for helping us figure out where uh, a line crosses the x-axis and where it crosses the y-axis. So you find those intercepts and then you're able to graph that line pretty easy peasy. So let me remind you that when you're finding your y-intercept, x is 0. When you're finding your x-intercept, y is 0. Okay, a little bit counterintuitive. So when x is 0, if we were to put 0 in for x, this whole term would just be equal to 0 because 0 times anything is always just 0. So 0 times 4 would be 0. So I'm just going to cover up that term because we know that's going to be a big fat 0. Now we're just solving for y. So 5 times what equals 20? So when x is 0, y would be 4 because we know 5 times 4 is 20. So there is our coordinate for our y-intercept here. Now, if we are solving for our x-intercept, we know y is going to be 0. So we say 5 times 0, well, that's 0. So we're going to put a block over that term. That's going to vanish. And 4 times what is 20? So we know when our y is 0, our x is going to be 5. Okay, so we've found our y-intercept and our x-intercept, and we can graph it from there. So now when we have a graph and we're trying to write an equation in slope-intercept form, the things you need to know are the y-intercept and the slope. So if we look at our graph right over here, you're noticing that the y-intercept is at 5. So we're going to write our basic slope-intercept form, y equals mx plus b. We know our b is going to be 5 because it crosses the y-axis over there at 5. And our slope, remember, it's the rise over run. So let's remember, it looks like we're going down 3 and over 2. So our slope is going to be -3 halves x, and then voila, we have it in slope-intercept form. It's pretty easy just looking at a graph. You find the y-intercept, you find the slope, you put it in this basic form. And then you could find any other point on that graph by putting in some value for x, solving the equation, figuring out what y is, and creating an ordered pair. Okay, point slope form is a type of equation that you would use if you are given a point and you know the slope. Okay, so in this graph, could we figure out the slope? We absolutely could. So remember, it's the change in y over the change in x. Okay, and then the slope. The slope is your m, and then you put in your point there where it's x and where it's y. So let's imagine that your slope is 2 and your point is 1, 2. Okay? Using this equation, you would say y minus, and our y is 2 here, y minus 2 equals, our slope is 2, times x minus 1. Okay? And that's it. You are done with point slope form. So our x value here goes right there. Our y value in this ordered pair goes right there. And your slope goes right here. Okay? And so we have taken the slope and a point, put it into point slope form, and that is as far as you have to go with this equation. Now, sometimes you may want to convert it into slope intercept form. So the first thing you would do is use the distributive property. Okay, 2x, and then 2 times the -1 is -2. So you have y minus 2 equals 2x minus 2. We want it to be in the y equals mx plus b form. So we want to get y alone. So we're going to say instead of subtracting 2, we're going to add 2. Whatever you do to one side, you have to do to the other. So we would say y equals 2x, and -2 plus 2 is just 0. So this is our equation in slope-intercept form. So we started with point slope form. You can rework the equation if you want to put it in another form, just using some algebra. Okay, if you are ever graphing y equals 5 or x equals 2, you have to remember to kind of say to yourself, okay, for any value of y, x equals 2. So x equals 2, x equals 2, x equals 2, x equals 2. Okay? And you're going to graph a line. Now, this is going to be an or a vertical line, okay, if x is equal to some constant. So you have to kind of talk you through this. If y is -1, x equals 2. If y is -3, x equals 2. For any value of y, x equals 2, and make those points on there. Now for this one, y equals 5, let's look at what that looks like. So we're going to go up 1, 2, 3, 4, 5. So y equals 5, y equals 5, y equals 5. For any value of x, y equals 5. Okay, and it'll look like that. It is a little counterintuitive because your y-axis goes up and down, but if you have y equals 5, it's a horizontal line, okay? And again, this has a slope of 0, and this is undefined. So we would say the slope of a vertical line is undefined. Okay, parallel lines. Parallel lines actually are super awesome when we are talking about slope-intercept form. Because if they are parallel, they are going to have the same slope. They're just going to have a different, whoa, a different y-intercept. Imagine that is parallel. All right, so if we say y equals 1/2 x, actually, let's say that's 2/3 x plus, what is that, about 4? Y equals 2/3 x minus 1. You're going to notice that the slope is the same for parallel lines. It's 2/3 and 2/3. And here, our y-intercepts are just different. So if you see the same slope, you know they're parallel lines. Okay? So if we look at our examples here, they both have a slope of 1/2, but they have different y-intercepts. So really easy to see that when you have it in slope-intercept form. If you are given a line and you're asked to analyze whether it is parallel or not, I would recommend rewriting it in slope-intercept form to be able to compare it. So if it's in standard form, rewrite it in slope-intercept form. So like if you have 2x plus 3y equals 1, to rewrite it in slope-intercept form, you would try to get y by itself. So we're going to subtract whatever else is on the same side as y. Remember our inverse operation, so that is 0. We're left with 3y, and then we have negative 2x plus 1. This is looking more like slope-intercept form, isn't it? But now we have to divide both sides by 3 in order to get y alone. And when you're dividing this side by 3, you have to divide each term on this side by 3. So this cancels out, and we're left with just y. And then we would have a negative 2/3 x plus 1/3. And now it is in slope-intercept form. So if you are asked to compare what two lines and determine whether they are parallel, or you would rewrite it in slope-intercept form and then double check the slopes. Now, if you are looking at perpendicular slopes, they would have a slope that is a negative reciprocal. So negative reciprocal of this means you're going to take 2/3, flip it, and then a negative times a negative would be a positive. So one slope is going to be negative, one slope is going to be positive, and they will be reciprocals. Now, if they are perpendicular, you should be able to multiply the slopes together and get a product of -1 every time. So negative 2/3 times 3/2 would give you cross cancel, would give you a -1. So if it's perpendicular, you can multiply the slopes together and get a product of -1. Okay? Or remember, lines that are perpendicular have opposite slopes. So take the negative reciprocal.